Ntike tutor, signing in. Today we're going to be looking at grade 12 mathematics. The topic I'm going to be looking at is going to be geometric sequences. Now, under the geometric sequences, you have the general formula there of Tn is equated to a r n minus 1. Now, there's a multiplication here, which we know that when two variables come together like that, that means there is a multiplication between them. So now, with that being it, let's look into an understanding what we are dealing with. So now here, it is going to be a. This a can also be, or it is, our term number 1, which is the first value on the sequence that which we are dealing with. And then now this r is going to be the common ratio that we use to move from the first term to the second, from the second to the third, and so forth. This is going to be it. How to calculate it? It's going to be, you can take term number 2, then divide it by term number 1. Or again, you could also say term number 3, then equate it with term number 2. But like I said, a common ratio. So that means if you take this and also if you take it the other way around, the answer you're going to get should be the same. That means that ratio is the same throughout. Now then, this n, it still represents our, it's still going to be representing our position. Term number 4, term number 3. But now Tn represents the occupier, the number that is going to be at that position. Like for instance, if I say term number 1 is equated to a, that means at position number 1, the value that is occupying that position is a. You get that? So T1, it is the one who is seated there. But n, which is 1, is representing what? The position number 1. I hope that makes sense. Let's just jump into a sequence that which we can handle. Let's say you have been given 96, 48, 24, 12. So now, the possible question to come, they can say, find, this is 12. They could say, find the last 2 terms, maybe, or 3 terms, however way they might want to. So the first thing you're going to need to do, or that you'll be required to do, is to find the ratio. So now, the common ratio that which we need to find, we're going to say that what? This, I'm going to use this, the ratio between these two values, it is going to be what? It is going to be found using term number 2 divided by term number 1, which means what? My term number 1 here at this case is going to be what? My term number 1, it is what? My term number 1, this what I'm going to get from here, it is going to be, let me just write it at the bottom, it is going to be what? Term number 2, which is 48, and then I divide it by 96. You get that? Then I'm going to do the same thing. This is 48, 96 at the bottom there. Now the same thing should be done between these two. So it is going to be term number 3 divided by term number 2, which I'm gonna get what? I'm gonna get 20. Term number 2 is 24 divided by 48. Then now, since I said it should be a common difference, if you take that 48 divided by 96, what do you get? 1 over 2. That means 48 goes twice into 96. So now, what do I have? Now, with me having this, I'm going to say a half here. That's what I get. Now, for this one, again, it will be what? It will be 24 divided by what? By 48, which is still giving me a half. So now what do I have? I have a common ratio, which is my R. It is common. So now that I have my common ratio calculated out, now this is my R. So now this ratio that I have should be the one I use to move forward. So if I want to find the term that is supposed to be at this position, I'm going to say what? I'm going to put 12, then I multiply it by what? I multiply it by the ratio. So 12 times what? Times 1 over 2, which is half. It gives me what? 6. So it is 6. And then the next one, it is going to be what? 6 times a half again. Gives me 3. So that is how you find values of moving further down. So now again, I can ask you to calculate the general formula. The general formula is that the formula we are going to use to calculate any number on the sequence. So with it being the case that which we have, now you still remember that I told you that, let me just swap the screen marker. I told you that we have the general as what? Stn is giving us what? Stn a Rn minus 1. That is what we have. So since this is what we basically going to be having, so now I have my A as what? As 96, and then I have my R as a half. Then I'm going to put them inside. Then I'm going to be having what? I'm going to be having 9, 6. Then I can open a bracket and then say half, close it, then n minus 1. That is how my formula will be. Do not find yourself in the reason why I used bracket here, I want you to see that do not find yourself in a position that after you have this, you want to multiply 96 with a half, then put everything to the power of this. Don't do that. Don't do that. Just leave it like this. This is going to be your general formula like this. So since this is going to be my general formula, it's supposed to be able to can work anywhere on my sequences. So now on my sequence, now if I look into this 24, what is 24? 24, it is the number that is seated on position number 1, 2, 3. On position number 3, I have what? I have 24. Let's say that I didn't know that it was 24. Then I wanted to can calculate that. So what was I gonna do? I was going to say that T what? 3 equated to, then what do I have there? I have 96. Where there is what? Where there is n, I'm going to put 3. Then this whole thing, if you put it inside the calculator, 96, open bracket, 1 over 2, close, then to the power what? 3 minus 1 will be to the power 2. Therefore, what do I get? 24. So that is going to be the value that is seated at position number 3. And indeed, it is 24. Now that we have that out, that is what you can use. So if they're looking for that, now again, let's say they give us, we can see that this value here, right here, you see, it's 6. Yes, I get that it's 6. But they ask you, is 6 part of the sequence? Then they say prove it with calculations. Now since they said prove with calculations, that you can't just right ahead jump in and say yes, it is part of the sequence because I can see it. No, you need to show them with calculations. So if this 6 is part of the sequence, it should have a position. It's more likely like if you are staying with us, you should have your own room. So now this 6 should be having a position in the sequence. So therefore, I'm going to write the formula, the formula of this sequence, which is this one. I'm going to say Tn is giving me what? Tn is equals to 96, open bracket, half n minus 1. Then again, what do I have? I take it as if I have the occupier, I need the position. So the occupier is going to be 6. So who is seated at that position? Number 6. What position is that? I don't know. I still leave it as n minus 1. You see? Now I'm going to attack the equation where it is weak. So the equation, firstly, before I attack the half is very strong because why? It is inside, it is embedded inside. So I need to take out these things that are on on the sides, just eliminate them before I can get the inside. So now I'm going to say what? The whole thing. Now I'm going to subtract this whole thing by what? By, I divide this side by what? By 96. What you do on the left, you're also supposed to do on the right. So now 96 there will cancel this one. So then what do I left with? I'm left with, what am I left with? Sorry, I'm left with 1 over 2 n minus 1. So you see now, with me having this, I'm going to bring into account what? My superhero, which is going to be what? Logs that has powers. So I'm going to introduce the logs. So since I'm going to be introducing my logs, I'm going to say the log of what? The log of this. It's like I have something like this. Let me just write what I already had, and then you see the logs for what they are. Now I have this side. But you also know laws of mathematics. What you do on the left, you also do on the right. So you see what I introduced? I introduced the log on this side and the log on that side. So now, the other thing that you should know is that a log has the powers. That's why I call it the superhero. A log has powers. So what powers does a log possess? A log has the power to make the exponent act as a base. So what do I mean by that? A log has the ability to can take this and put it there next to this log of half. You get that? So now I'm going to do just that. So I'm going to be, this side is still the same. So I'm going to be having log of what? 6 over 96 equated to what? That n minus 1 close, then what? Log of half. So now that this is what I have, let's make use of brackets because of what we're going to do next. Now this is what we end up with, but then again, you still remember, I want to isolate n. I want n to be the carrier of the formula. So I need to eliminate and take out this from there. So I'm dividing here by what? The log of half is what I don't want. So I'm dividing by log of half. So what you do on the left, you also do on the right. Log of half. So therefore, what do I get? Excuse the noise. What do I get? Now, I get that this part, this log half will cancel this one here. So I'm going to be left with, I'm going to be left with what? I'm going to be left with what? From there, that other side will still be the same. It will have log of 696 divided by the log of half equated to n minus 1. So that is basically what I have on that side. So now since this is what I basically have, what do I do with that? I'm going to say take this, shift it to the other side, it will add. You get that? So I'm going to say, since it will add, therefore n is equals to, so that means I'm going to put this inside the calculator, which is going to be the log of what? The log of 6 over what? 96 divided by what? The log of half. And then because this one was negative, when it moves to that side, it will be positive. So I will add it to the whole thing. So what do I get? I get 5. So n is equals to 5. Now that means what? That means 6 is seated on position number 5. That means it is part of the sequence. Let's just go and confirm because we had already calculated it for ourselves. This is term number 1, 2, 3, 4, 5. This indeed is seated at position number 5. This is term number 5. Okay, I hope that makes sense. Now the other form of question I wanted to also handle will be this type, the one whereby they give you your sequence that is not like this. They give you sequence by parts. For instance, they tell you that you are given at term number 1, not term number 1, sorry, they normally skip term number 1, then they maybe say term number 2 you have 48, term number 1, 2, 3, 4, term number 4 you have 1, 2, 3, 4, you have 12. Let's say now they've given you this information here. This is the information that which we had been given. So now I know we already know that our general formula is there. The reason why I'm using this very same sequence that which you've seen is because I want you to get that if it is wrong, you can already see for yourself that no, but you got an answer that is different from what we had on the previous calculations. So that means there is something wrong we are doing. Now, let's say you have been given this as a sequence. They say given term number 2 is 48, term number 4 is 12. Then they say what is going to be the value of term number 6? What is going to be the value on term number 6? That's the question they ask you. Without making calculations, you can't see. From there, you can see it. But remember, the sequence is not given like this. They have given us only this. But we need to make calculations to find the term number 6. But then again, now, this is how you're going to approach it. You analyze the given information. You ask yourself, like, for instance, here, what I have. So with what I have been given there, with what I have been given here, I'm going to say that term number 2, let's say I was not given that it's going to be at term number 2, it's going to be 48. I was going to write the formula term number Tn is equals to Arn minus 1. Then where there is 2, I was going to put n because I know term number 2. So I want to find what number would be there. I can see we have it, but let's just go with me and you'll see. Term number 2 is going to be what? Arn. My n is 2, so it will be what? 2 minus 1. This is what I end up with. But then again, I already know that term number 2 is what? Is 48. So where there is T2, I'm going to put 48. So therefore, I'm going to be having 48 equated to what? Ar to the power what? N minus 1 will be 1. 2 minus 1 will be 1. So this is what I end up with. So this is going to be my equation number 1. How to make my equation number 2? This 4, the same thing, but where there is n, I put 4. T4 is going to be what? Ar what? 4 minus 1. So then again, where there is T4, I'm going to put 12. So I'm going to be having 12 is equated to what? Ar to the power what? 3. So this is going to be my equation number 2. Then now, I can take any equation that I want to make either R or A the subject of the formula. So I choose to make A the subject of the formula from the equation number 1. So I'm going to say from equation 1, I'm going to make equation 3. So on equation 1 there, you can already see what we have been given. On equation 1 there, we have what? We have 48 equated to what? Ar. So I want to make A the subject of the formula. So I'll divide both sides by R. So therefore, A will be what? A will be equated to what? 48 divided by R. So this will be my equation 3. So then I'm going to say what? I'm going to say sub equation 3 or A sub equation 3 into what? I can't sub it into equation 1 because it was made from equation 1. So I'm going to sub it into equation 2. So therefore there, where there is what? Where there is into equation 2. Where there is A, I'm going to put what? 48 over R inside there. So what do I have there? I have 12 equated to a. Then I open a bracket. I say what? 48 over r, close bracket. What do I have? R to the power 3. Then I have what? 12 equated to. You know that this r to the power 3 is like a 1 there. So therefore, this will multiply with 48, and then the 1 will multiply with r. So therefore, I'll end up with what? With 48 r to the power 3 divided by what? By r. Then now, what will I end up with? That side, I'm going to say r into that one. So therefore, the power at the top minus the power at the bottom. So 3 minus 1, I'm going to end up with what? With that side, it's still 12. So this side, I'll be having 48 r to the power 2. So then now what do? I want r to be the subject of the formula. So what do? I divide here by 48. What you do on the left, you also do on the right. So this is what I end up with. So now this 48 will cancel 48. I'm going to be left with what? R squared is equated to what? 12 48. Because I want the value of r as a single unit, not r to the power 2. I introduce a root on this side, a root on the other side. So therefore, r is what? R is going to be the root of 12 over 48. I get r is what? R is half. So now that I have the value of r as a half, I also need the value of a. Now I'm going to take what? The equation number 3, because a is already what? Carrier, the subject of the formula at that point. So I'm going to say a is equals to, where there's r, I'm going to put what? I'm going to put a. I'm going to put half, sorry, where there is r. So I'm having 48 divided by a half. So 48 divided by the half is going to be how much? 48 divided by a half. It gives me 96. So therefore, a is equal to 96. So then I go into my equation. I substitute the value. So therefore, Tn is equals to what? A is 96. Open bracket. R is half. N minus 1. This is what I have. So if I wanted to find the value of term number 6, it will be easy now. I can just say what? I can just say where there is n, I put 6, and then I get the value of term number 6. So you needed that to can calculate moving forward. I hope that makes sense. Now the other part or form of question I wanted to handle would be the one whereby you are dealing with geometric sequences, but then now here at this point you are forced to can calculate solve for x. Let's say you have been given this type of question where they can give you x minus 6, 2x minus 6, 5x plus 3. So now if this is what you have been given and they say maybe let's say on this one you are expected to solve for the value of x. They say solve for x. Now the question said solve for x. So how will you solve for x, given that they will give you that this is a geometric series? Now if they've given us that it's a geometric series, this is how we are going to handle it. So we are going to firstly look at a geometric series. What does it possess with? You know that in a geometric series you're going to be having r. But now that r is not just any r. It is going to be a common r, which will be the same throughout. And then the calculation of this r, if I took term number 2 divided by term number 1, it will still be the same as if I could have taken term number 3, then divided by term number 2. If you're asking yourself, why did I make this? Look at what we have on my equation. If I just make use of brackets like this so that you can see them for what they are, then I could say this whole bracket is term number 1, this whole bracket is term number 2, this whole bracket is going to be term number 3. So now that I have that, I can just put where there is those T1, T2, I put the bracket I'm basically going to be looking at. So now there, term number 2 is this bracket. So therefore, I'm going to be saying, making use of bracket, 2x minus 6 close, divided by term number 1, it is going to be what? X minus 6 close. Then the whole thing equated to term number 3, it is what? 5x plus 3 divided by term number 2, which is what? 2x minus 6 close. So now that I'm at this stage, now I can solve for x. Now I can cross multiply this with this with that. So now if I'm going to cross multiply like that, what do I end up with? This bracket with that one. So I'm going to be having x minus 6, 5x plus 3 close bracket equated to 2x minus 6 close 2x minus 6. That is what I'm basically going to end up with. So now, with this being what you have, now let's move it further down to say this, you break the bracket, the first bracket with the second bracket. So I'm going to be having what? This a 5x multiplied with x, I'm going to be ending up with 5x to the power 2. Then this x multiplied with that, I'm going to be having plus 3x. Then now, this 6, negative 6 times that, I'm going to have what? Negative 6 multiplied with 5. I get negative 30. So I'm going to say minus 30x. Then this negative 6 multiplied by what? By 3. I get negative 18. No x because there was no any. Now this side, I'm going to make the same thing. This 2 times that, I'm going to end up with what? With 2x to the power what? Not 2, sorry, 4x to the power 2. And then again, I'm going to say this 2 again with that 6. So I'm going to get what? I'm going to get minus 12x. And then again, this negative 6 with this 2x, I get negative 12x. And then negative 6 and negative 6, I'll get a positive. Negative 6 multiplied by negative 6, I get a positive 36. So plus 36. Then now I collect like terms, both on the left and the right. So firstly, I start off by the right, collect, then go to the other one, collect, then mix them after. So then now what do I have? This one doesn't have a like term here, so I'm going to be having 5x to the power 2, but now this and that are like terms, so I'm going to be having negative 27x. Now minus 18 is equated to, then now this side, this doesn't have a like term, so it is still going to be what? 4x to the power 2. But now this and that are like terms. I'm going to get negative what? I'm going to get negative 24x plus 36. Then now I fully solved this side, so that side also. Now I move this, I move it to the other side. Why? Because I don't want my highest x power to be having a coefficient that is negative. So if I put this one, this negative, this 5, take it to the other side, it will be negative. So, and then the answer that the coefficient of x squared will be negative. I don't want that, so that's why I'm taking these to the other side. So let's just take them while working them out. Let me use a different color marker. Here, if I have this one, 4x to the power 2, take it to that side, what do I get? Its like term will be this one. So we're going to be having 5x squared minus 4x to the power 2. So I'll end up with what? X squared, like that. Now this one, I'm going to be having negative 24. I take the negative 24 to the other side, it becomes positive. So then now when it becomes positive, I'm going to be having what? I'm going to be having a negative, because the biggest one, it is negative. So what do I end up with? I'm going to be ending up on this side, I'm going to be ending up with a value of 3. I'm going to be ending up with a value of negative 3. And then now not forgetting the x. And then this one, 18. And this one. So 36 going to that side, it will be negative. So they will combine. So 36 plus that 18, I'm going to be having 54. That is going to be negative. Let me just compare that one. 27 minus 24. Yeah, it's 3. Then the whole thing will be equated to 0. So now that this is what I have, I'm going to make use of 2 brackets like that, equated to 0. Then I say x. Then I say I'm going to look for two numbers that which when you multiply, they give you 54. But when you add or subtract, they are going to give you the middle term. Or if you want, you could also make use of the quadratic equation, which is the one of x equated to I'll bring it down for you to see, or let me just say it out to you. Or you can make use of a quadratic equation, which is what? X is equals to negative b plus minus the root of what? B squared minus 4ac, the whole thing divided by 2a. That is your quadratic equation. I hope that makes sense. Now on this one, the two values that which you're going to be having are going to be what? We need to find them. So let me just say 9, 6 and 9. That's 6 times 9, 54. And then now 6 and 9, 54. So if 6 and 9 is 54, we need the middle term. So for the middle term, I could say for the middle term is negative, so I'm going to make the bigger one to be negative. So I could say 6 minus 9, I get negative 3. So I have what? 9 and 6 to use, but the 9 needs to be the one that will be negative, right? It's going to be negative, but then the other one needs to be positive. So therefore x can be what? 9, or it can also be negative 6. So that is basically what you have, what you will be dealing with. Those are the possible questions to be asked under geometric sequences. So ladies and gentlemen, this is me, MTK the tutor, signing out.